Okay, the last of these solve by factoring questions is example 4. There are 3 of them, and what makes these ones different is that they are composite. But what does that actually mean for us? Well, really nothing. So we need to make sure that just like the previous ones, we set it equal to 0. That's done. Check. And then we need to factor, and then we need to do 2 equations, this or that. So that's what we're hoping for. However, this factoring, because it's composite, has maybe an extra step or 2. Let's factor it first now that it's equal to 0. So on this side, we've got a 1 and a 1, and an x plus 1 and an x plus 1, because that gets you the x plus 1 squared. On the right, we need a 3. 3 times 1 is 3, but it needs to be negative. So I'll make one of them negative. Then you can check your diagonals. This is a 3x plus 1. That's a negative 1x plus 1. And if you add them, you get 2x plus 1. That is what we have in the center there. So we know we've done it right. And just like the composite functions, I'm going to put these red square brackets around. And I have factored it to be 1x plus 1, 1x plus 1 minus 1. And 1x plus 1, 1x plus 1, and then a plus 3, or positive 3, equals 0. So I'm just going to erase this stuff off to the side here, or maybe just move it. Now, we've got 2 things. Oh, actually we don't. We should probably simplify it first. So there's 1x, or just an x. 1 plus 1 is 0. And the other one is a 1x, or just x. 1 plus 3 is 4. Yeah, that looks good. So now we can separate it. We have x is equal to 0, or x plus 4 equals 0. Now this is already done. X is already alone. And this is not alone. You're going to have to minus the 4 onto the other side. So x equals minus 4. If you don't know how to do that, you can watch some of the earlier videos, but those are my 2 answers. So how is this different than the other ones? Well, there's some composite function work there, which does not make much difference in this step, but it does make a little bit of difference in this step here where we have to do a little extra simplifying. Let's try another question here. Okay, so we've got 1 minus 2x, 1 minus 2x, perfect, but it needs to equal 0, so we'll minus the 4 over to this side. Now this is a term, and this is a term, and we can't combine them because this one is squared, and this one is to the power of 1, so they're not like terms. And 4 is another term altogether. It doesn't even have a bracket of 1 minus 2x. So this is 2, 1 minus 2x squared, plus 7, 1 minus 2x minus 4 equals 0. So we've got the left side here, we've got the right side, and then we've got the middle. And notice that this is squared, and then the power of 1, and then nothing. So we haven't done a question like other than the one that we just did over here. We haven't done a question like this. You would have seen it written 2x squared plus 7x minus 4 equals 0. That is a question that you would have seen before, but now this is composite functions, meaning there's something else, there's an extra bracket in there. Oh, I wanted to keep that middle. So we need to factor this like normal. 2 is probably a 2 and a 1, and then this is 1 minus 2x and 1 minus 2x to get you a 1 minus 2x squared. This side is 4. So I want to say 2 and 2, but I think the answer is actually 4 and 1, and it needs to be negative. So this diagonal is going to be an 8. 4 times 2 is 8. 1 minus 2x. This diagonal is a negative 1. 1 minus 2x. And if I add those, I get 7. 1 minus 2x's. And that is what I have right there. So I know I have factored it correctly. So I've got, oh, I wanted to use the red pen here. I've got this one. So I've got 2 minus 4x, 2 minus 4x, and then I got this minus 1 here, minus 1. And then I got this one, 1 minus 2x, 1 minus 2x, and then a positive 4 is equal to 0. So because it equals 0, I can create two things here. Oh, actually, I made the same mistake again. It's not a mistake, but I'm just jumping ahead a little bit. I've got a negative 4x, so a negative 4x, and I've got a 2 and a minus 1. 2 minus 1 is 1. And then I've got a negative 2x right there. And I've got a 1 plus 4, which is a 5. So I just simplified it there. Now that this is a little simplified, I can do this. So I've got a negative 4x plus 1 equals 0, and a negative 2x plus 5 equals 0. So there's this, or there's that. Now you should immediately be able to say, oh, this is going to be negative 1 over negative 4, or a quarter. And this is going to be negative 5 over negative 2, or 5 over 2. That's how fast you should be at this. In your head, you should be seeing, okay, this is a grade 9 or grade 8 algebra question. I got to subtract the 1 and then divide by negative 4. So that's what I did. Subtract 1, divide by negative 4. Done. And here you should see in your head that you're going to subtract the 5, and then you're going to divide by negative 2. So that should be really, really quick. I'm going to do the steps for this first one here, though, for you. So I'm going to minus 1, subtract the 1, like I had said. Negative 4x equals negative 1. And then divide by negative 4. Divide by negative 4. So like I said, subtract the 1, divide by negative 4. Negative 1 over negative 4, which is going to be just a positive 1 over positive 4. Same with this thing, you're going to subtract the 5 over, so I'll write negative 2x equals negative 5. I'm not going to show that, I'm just going to subtract it over to the other side. And then I'll divide by negative 2 to cancel that out. So x equals positive 5 over 2. The two negatives will cancel. And so that is a very big question. There's a lot going on in that one. You have to do a factoring. First you got to move over the 4. It's not a like term, so you just tax on to the end, like you see here. Then I factor it. Then it's a composite function, so I got to bring the 2 in and bring the 1 in and add like terms. Then I can actually just do the two separate equations here and solve them. Okay, so I'm going to have to just shrink this. Put it over here. It's going to be quite messy, but that's just the way it is. Now this one, I've got my left side, it's already equal to 0, and I got my right side. I'm missing my middle. So immediately, the only time you should know that, oh, if I'm missing the middle, it's probably a difference of squares. Sure enough, you see that the 4 here, that's a perfect number. That's a perfect number. There is a difference in there. There is a subtraction. So they must be a difference of squares. These are perfect squares. So 2 and 2, 3 and 3. One of them is negative. And this needs to be 2 minus x and 2 minus x in order to get the 2 minus x squared. This needs to be x minus 5 and x minus 5 in order to get the x minus 5 squared. And I'm just going to get rid of that. And my diagonals are going to be 6, 2 minus x, x minus 5. And this one's going to be negative 6, 2 minus x, x minus 5. So if I added them up, I get 0. 2 minus x, x minus 5. 0 times anything would just be 0. It's gone, which is why there is no middle term. It's disappeared. It's 0. So I've got my two factors right here. It's going to require a little bit of work. So this first one is 4 minus 2x, 4 minus 2x, minus 3x plus 15, minus 3x plus 15. And the second one is going to be 4 minus 2x, 4 minus 2x, 3x minus 15. So a positive 3x minus 15. Great. Now I've just got myself stuck because I've written so largely here. And that is equal to 0. So I can simplify that for these. I've got a negative 2x and a negative 3x, which is a negative 5x. And 4 plus 15 is going to be a 19. And then I've got a negative 2x and a positive 3x, which is a 1x. And then 4 minus 15, I guess, is negative 11. So I've got 2 here. I've got a negative 5x plus 19 is equal to 0, or an x minus 11 equals 0. So I just didn't write the 1. And immediately, you should see that this is going to be negative 19 over negative 5. You're going to bring this negative 19 over by subtracting it. So subtract 19. And then you're going to divide this 5. Divide by 5. And that one will be 19 over 5. I'm going to just make them positive. And here you're just going to bring that over by adding it. So x equals 11. So those are my two answers. So what makes C a little bit different is simply that it's a difference of squares. There's no middle term. The middle term got me a 0 like you see here. So those are the 3 questions. I love putting these ones on tests or assessments. And let me just make sure I got everything in here. And you really show that you know your stuff if you can solve these questions. There are some practice ones in the worksheets if you need extra practice.